Hey, it's Mr. Wolf. Today we're going to catch up on benchmark 9. We'll call this 9.2. We're just going to fill in a few gaps left in this particular benchmark in which we talk about congruence and how we prove congruence by transformations. This image should look familiar. This was on your worksheet. This is an example of proving congruence by translation because if we slide this figure down, it'll match that one, proving they're congruent. This one is rotated 270 degrees this way, and it would match up or map to this figure. And this is a reflection over the y-axis, okay? So that's essentially all we're doing. Okay, first let's look at properties of rigid motions. Remember, rigid motions are isometric, meaning they don't change, or that size and shape do not change. Okay, we'll use these two figures for example. So rigid motions preserve distance. So for example, this side is 5 long and its corresponding side down here is still 5 long. So distance is preserved. So are angle measures. This angle here is the same as its corresponding angle down here. And collinearity. So if 2 points are on the same line, then they remain on the same line no matter what. Rigid motions do not preserve location though. And that should seem obvious. These might be the same size, same shape, but they are in 2 different spots. So location is the one that's not preserved. Next, CPCFC is a new term to us that we've already learned. It stands for corresponding parts of congruent figures are congruent. Whew, that's a mouthful. Okay, let's break that down. Corresponding parts, well, we know corresponding parts are parts that match up. So for example, this right angle here is A, so this right angle over here would be A prime. This angle here is B, and its corresponding angle is B, and that makes this C. What we know is since these two triangles are congruent, then the corresponding parts are also congruent. So angle C is congruent to angle C prime, and A to A prime, and B to B prime. And it's the same for the sides. Side BC is congruent to side B prime, C prime. So when the shapes are congruent, the corresponding parts are also congruent. Next, how do we determine if it's a rigid motion? Okay, let's look at figures first. These two are a rigid motion because we could do a couple of transformations and you'll see they match right up, right? So we know those are congruent. These, on the other hand, well, that's not going to work. They're not the same size, so they are not a rigid motion. The star looks like it rotates, but then this one is also stretched, so not a rigid motion. Only this one is. What happens when we don't look at figures, but we look at terms? Okay, so if we look at xy turns into x plus 2, y minus 3, is that a rigid motion? Yes, it is. It's just a translation. We add 2 to the x, subtract 3 from the y. How about here? If we rotate this figure by 90 degrees, yep, it's still a rigid motion. It stays the same even when we rotate it. If we reflect it across the x equals 2 line, yes, that's a rigid motion as well. So all of these are rigid motions. This one, however, is not a rigid motion. It is not because we are multiplying x and multiplying y by 2, and when we multiply by 2, the figure gets bigger, twice as big, in fact. Here, all we did was flip x and y, and that is a rigid motion. Last, if we triple x but cut y in half, is that a rigid motion? No. So anytime we multiply or divide, something like that, it's not going to be a rigid motion. All right, and last, let's look at how we can prove congruence through transformation. All right, so we want to prove this red triangle is congruent to the red, and we can do that through 2 transformations. All right, the first thing I'm going to do is I'm going to rotate this shape. So that's the first transformation. All right, so I would write a rotation of 180 degrees. Next, I'm going to do a translation, and it looks like it's going to go over, let me grab it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to the right, and 1, 2, 2 up. So that would be a translation of positive 11, positive 2, okay, because we went over to the right 11 and up 2. Those are both positive. All right, over here, we want to map this triangle onto the blue. Okay, so what do? Let's try doing a rotation. Okay, when we rotate, now I see, okay, these figures match up. And then again, I'm going to slide it down or translate it down and then over. Actually, I should have done over and then down, X then Y. Ooh, but I do that and I see they don't quite match up. Huh. Well, maybe it wasn't a rotation to begin with, all right? Maybe instead it was a flip. So I'm going to flip it, okay? And then I'm going to rotate it. Aha. And then I'm going to translate it. So this one actually had 3. Okay, first I had to reflect it, then I had to rotate it, and then I had to translate it. And so I would write down all of those rules down here. That's what you're expected to do on your worksheet as well. Let me know if you need any help.